Hello grade 12s and welcome to the last video in the series of theory videos on momentum and impulse. So far I've been revising the theory with you, been showing you a few short examples. In the videos to follow this one we will look at longer questions, mostly from past papers. So elastic and inelastic collisions, what is the difference? We say that elastic collision or an elastic collision is a collision in which both total momentum or total linear momentum and total kinetic energy are conserved. The most important part of this statement is that the total kinetic energy is conserved. We say that the sum of the kinetic energy in the beginning, directly before the collision, is going to be equal to the sum of the kinetic energy directly after the collision. Right? Remembering that to calculate kinetic energy, we say half mv squared. Normally, when you see or when an elastic collision happens, there's no deforming, there's no joining. The internal energy is constant, so in other words, no energy is lost in the form of heat or light or deformation. And most importantly, grade 12s, we say that the kinetic energy is conserved. So if you would like to prove that a collision is elastic, you're going to add the kinetic energies of both objects before the collision. Then you're going to add the kinetic energies of both objects after the collision. You're going to see if they're equal to each other, and if they're equal, then it means that we have an elastic collision. The closest example to an elastic collision that we have is a bouncy ball. Right? So when a bouncy ball hits the ground, there's no permanent deformation, and normally when it's the first time it's hit the ground, it bounces back to almost the same height because kinetic energy is conserved. Alright, so on to elastic collisions. We say an inelastic collision is a collision during which kinetic energy is not conserved, and that is very important. If we would like to prove that a collision is inelastic, once again we will add up the kinetic energies before the collision, but we're going to find that this kinetic energy is not equal to the kinetic energies that we add up after the collision. Okay, so that's how you're going to prove that a collision is inelastic. First, you're going to add up the kinetic energies before the collision. Then you're going to add up the kinetic energies after the collision. If they're not equal, then it means the collision is inelastic. Normally, when an inelastic collision takes place, there is permanent deformation. For example, in the case of two cars that bump into each other. We know that if we have a head-on collision, then the car bonnets will be damaged. We have an inelastic collision when objects join together after a collision and move as a unit. We have an inelastic collision when the internal energy increases or changes. Or we can say if the kinetic energy is lost. So if kinetic energy is lost in the form of heat or damage done, then we know that the collision is inelastic. So now let's look at an example of a question that requires us to calculate or determine whether a collision is elastic or inelastic. This question says, a truck traveling at 40 kilometers per hour east with a mass of 950 kilograms crashes into a car with a mass of 300 kilograms that is traveling at 60 kilometers per hour west. Immediately after the collision, the truck travels at 10 kilometers per hour in its original direction of motion, and the car travels at 35 kilometers per hour in the direction east. Was this an elastic or inelastic collision? Well, firstly, we have a lot of information to work with here, so let's start off by listing the information we have. We also need to decide on which direction we're taking as positive, although it's actually not very important in this question. So east, we will take east as positive while we are listing our values. So we have the truck and we have the car. The initial velocity, or we can even say the initial speed, let's use speed, of the truck is 40 kilometers per hour. Okay, then we know the final speed of the truck is going to equal to 10 kilometers per hour, and that is in exactly the same direction, the direction that we have chosen as positive. The truck has a mass that is equal to 950 kilograms. When we look at the car in this case is a very small car. It only has a mass of 300 kilograms. Its initial velocity is negative, and that is negative 60 kilometers per hour. So everything is given in kilometers per hour. This means that we're going to have to do a conversion. And the final velocity is given as 35 kilometers per hour, and that is towards the east. So here we have a negative direction, and over here it is in the positive direction. So before we do anything else, it is very important that we convert these values. To go from kilometers per hour to meters per second, we're going to multiply by 1000 over 3600. Because to go from kilometers to meters, we multiply by 1000, and to go from hours to seconds, we multiply by 60 and then multiply by 60 again, which is the same as multiplying by 3600. So let's start off by converting all of these speeds to meters per second. So now, as you can see displayed to your screen, we have the speed in the correct SI units. So let's start off by finding the sum of the kinetic energy before the collision. This is going to equal to half m of the truck, v of the truck initial squared, plus half m of the car, v initial of the car squared. That is going to be half. The mass of the truck is 950. Whether you plug in the positive and negatives in the speed or velocity is not important because it's going to be squared. Okay, so over here we're going to plug in 11, that is this value, and we must not forget to square it. Plus we have half. The mass of the car is 300. Its initial velocity is given as a negative 16.67, and we must not forget to square this value. We plug this into our calculators and obtain 100,313.58 joules. Kinetic energy is energy, and therefore it's measured in joules. This is the kinetic energy before the collision. So now we need to calculate the kinetic energy after the collision, and notice that I'm calculating each of these on their own. So we're going to say half the mass of the truck's final velocity squared, plus half the mass of the car's final velocity squared. The masses are still exactly the same, so that of the truck is 950, but its final velocity we calculated as 2.78, and we must not forget to square it. And we have half. The mass of the car is still 300. Its final velocity is 9.72 meters per second. And now we can take all of this and plug it into our calculators. As expected, since this is a collision between two vehicles, the sum of the kinetic energy after the collision is only 17,842.75 joules. Now we compare and we see that this value is not the same as that value. So we say, therefore, the sum of the kinetic energy before the collision is not equal to the sum of the kinetic energy after the collision. And as a result of this, we can conclude that the collision is inelastic. And grade 12, so this brings us to the end of this video. In the next video, and a few to follow, we're going to go through a few exam paper questions. So please join me in those videos.